So, this is the third week of the course on Newtonian mechanics with examples, and we were discussing the condition of mechanical equilibrium or the statics. So, let us get started with some examples. So, in the previous lecture we calculated the moment due to on a gear, and we calculated using several different methods to highlight different aspects about the concept of moment. So, this is so today we are going to take few examples. So, the first example is again a gear, but this is slightly more complicated situation than the previous example. So, instead of one gear we now have a gear set. So, it is a system of 3 gears, all of them have the same center. So, they are concentric system of concentric 3 gears. So, the problem says that, so there are 3 forces acting on this gear set as shown by these arrows. So, one force each on a different wheel. The question asks, determine the x and y intercepts of the line of action of the resultant of the 3 loads applied to the gear set. So, let us analyze what is required slowly. So, the first thing is that if we sort of first, as we said, we need to define our system. So, in this case our system, so this is our box which is our system, and this system is the gear set, that is the 3 gears together. So, we are going to choose this as our system, because the obviously then all the forces will be external forces. Note that these gears are not sort of seems to be stacked on top of each other. So, they are not, I mean their rotations are independent of each other. Then the interactions, so the interactions are the 3 forces F1. So, let us call this force as F1, sorry, let us call the inner gear this force as F1, and the second gear as F2, and this third gear as F3. So, the interactions are F1, F2 and F3 shown in the figure. And what, so let us understand the problem. What we need to calculate? We need to calculate the resultant of these 3 forces. So, what is the total force acting on our system? So, the total force acting on our system, let us call that F net, and this is simply F1 plus F2 plus F3. So, this is fine, but this is not what the problem asks. The problem asks that find the x and y in the line of action of this force F net. So, the point is that if we replace all these 3 forces by a single force on our system, then where we are going to apply this force? This is the question. And how do you determine? Because it is basically arbitrary. So, we can determine by saying that, so we are going to replace this force, and so you have to demand this condition that the resultant force must generate the same amount of moment as the generated by these individual forces. So, the total moment must be same, then the state of motion will be same if we replace these individual forces by a resultant force. So, this is the question, the aim is same. So, let us proceed further. So, the first we need to calculate the total force. Now, this total force, this part is easy. So, this F1, so let us write down the individual forces first. So, F1, so this coordinate system in this case are provided like for our convenience. So, all the forces have only x component and y component, there is no z component. So, this is our So, we said that this is our F1. So, it has two components. This is our F2, it has two component, and this is our F3, it has three components. So, F1 from this diagram, it is clear that this is 20 degree, this is 20 degree. So, F1 is minus F1 sin 20 degree x hat plus F1 cos minus cos 20 degree y hat. F2, so it has a positive x component. So, F2, so this angle is 20 degree. So, F2 cos 20 degree x hat and minus F2 sin 20 degree y hat. So, F1 is the magnitude of F1 is, so these are the meaning of the symbols. And F3 is minus F3. So, this is again 20 degree cos 20 degree x hat plus F3 sin 20 degree y hat. So, the resultant is just a vector addition. So, this is, so the x component, let us call that x. So, that will be given by minus 1.5 kilonewton times sin 20 degree plus 2.4 kilonewton times cos 20 degree and minus 3.6 kilonewton times cos 20 degree. Now, so the scale kilonewton Kn represents 1000 Newton. So, now if you plug in the values, you will get final answer is 641 kilonewton. Now, if we similarly calculate the y component, so you add this plus this plus this, you get minus 1.5 kilonewton times cos 20 degree minus 2.4 kilonewton times sin 20 degree and plus 3.6 kilonewton times sin 20 degree, which is equal to, so if you plug in the values, you will get this value. So, this is the resultant force. Now, our question is that, so let us first draw this force. So, this both of them has negative components. So, that means this is the x component and this is the y component. That means the force must be along this direction. Now, does it make sense? So, you can see from this picture that the vertical direction, the y component of the largest magnitude of y component of the force coming from F1, and from the x component, the horizontal component are F2 and F3. So, you should make sure that these, if you draw it to the scale, then you should get that the x component and y component of the resultant force is as shown here. Now, the question is, so this is my pivot point. Now, what is the, where should I apply the force to generate the same amount of torque or total moment? So, suppose our point of application of the force is this point. So, let us say the point of application is some point which is position vector is r, and this r has x component and y component. So, then the what is the moment of this total force acting at r? So, that we can calculate from this definition. So, we take the cross product and it shows, okay, let me write it here. So, it gives you only, you can see, you can verify there will be only z component, x component and y component both will be 0. So, the z component would be x times f y minus y times f x. So, I have simplified that f net is f. So, I have removed, omit this index net to reduce writing. Now, how much is the force torque generated by these individual forces? Well, you can apply, that will be given by R1 cross F1 plus R2 cross F2 plus R3 cross F3. So, this is R1, this is this is R1, this is on the second wheel. So, this is R2 and this is the point of application of the third force, this is R3. So, we get the R1 is x1 x hat, R2 is, so where x1 is equal to the radius of the first inner wheel, which is given by 0.120 millimeter, which is 0.12 meter. R2 is acting on at this point on, which is on the y axis. So, this is given by the radius of the second wheel. So, the radius of the second wheel is 200 millimeter and R3 is, the radius is acting on the y axis. So, this is the radius of the third wheel, the largest wheel, and this is in the negative direction. So, we can see that if we apply the R cross F definition on individual force, we can see that all of them produce the moment or torque in the same direction. So, we can, so in this situation, since the point of application of F1, F2, F3 are only on the x axis or y axis, so our calculation is simple. So, our moment coming from each individual direction, we can simply calculate the magnitude, and it, so we can say that this m1, the first term is nothing but 1.5 kilo Newton times. So, as we can see, this, we discussed in the previous example that for the F1 only the y component is going to contribute. So, the y component is into, so we have written the y component here. So, F1 cos 20 degree times this distance, so here, so put the force here. So, only the y component is going to contribute times 0.12 meter. So, let us call that. The second term will be R2. So, in this case only the x component, because the line of action, if we sort of move the R2 here, F2 here, we can see that the line of action of the y component is passing through the pivot point O. So, only the x component will contribute, and the x component was F2 cos 20 degree. So, this is 2.4 kilonewton cos 20 degree times 0.2 meter, and plus similarly for the force F3, if we take, we move it along the line of action. So, then the y component is of this force F3 is passing to the pivot point, it will not contribute to the moment, only the x component will contribute, and that x component was minus F3 cos 20 degree. So, minus 3.6 kilonewton cos 20 degree times 0.3 meter, and this will turn out to be 1. Note that I am adding this magnitude. So, this is possible because the direction of each of these torques are same, they are all directed in the along the z axis. Hence, we can simply add the magnitude to calculate the total torque. So, the vector addition in this particular case becomes just a simple scalar addition. So, then we have this condition that we have calculated the torque. So, this is the torque due to the resultant force, and this is the total torque by the individual forces. So, they must be same. So, if we equate them, so there must then we get an condition that x times f y minus y f x. So, now if we put the, we can see that from the thumb rule the direction is going into the page. So, I add a minus sign to denote that. So, now we demand that these two torques must be same. So, that is how we determine the line of action. So, then we get, so note that in this case we cannot determine the exact point of application. There is no meaning of an exact point of application. We can only determine the equation of a line. So, note that this is an equation of a straight line. So, because along this line of action you can apply the force at any point and it will give the same amount of torque. So, you cannot determine precisely the line of the point of application. All you can determine is the line along which you should apply the resultant force to generate the same amount of torque. Now, the question asks for the x and y intercept. So, what do I mean by that? It means that suppose this is my x axis and this is y axis, I draw again, and so this force is directed along, we determine the direction of the force. So, this must be the line of action in some sense of the force. So, then we need to determine the position of this point where it intersects x axis and the position of this point where it intersects y axis. So, this is the direction of the force. So, this point we can demand that at this point, so this is the x intercept. So, the condition of x intersecting x axis is y coordinate must be 0. So, let me write down the equation again. So, x times f y minus y times f x is equal to minus 1.635 Newton meter. So, if I put y equal to 0, then the value of x, let us call that x naught, is given by minus 1.635 Newton meter divided by the Fy. So, the Fy was, so we computed here. So, this is our Fy, which was minus 0.999 kilonewton. So, minus 0.999 kilonewton. So, and here I am sorry, it must be a kilonewton meter. So, the value of this turns out to be 1.637 meter. So, note that I am deliberately writing the units so that we do not make any mistake with the units. Similarly, the y intercept is given by x equal to 0, and that is this point. So, let us call that y naught, and this will be given by the condition in this equation you put x equal to 0, then this is given by minus 1.635 kilonewton meter divided by minus of f x. So, minus of f x is 1.641 kilonewton. So, this is which is equal to 0. Almost like 1 meter. So, note that we get the correct sign, because if we expect that the force is along this direction, then we expect the x intercept is positive and y intercept is negative, and this is precisely what we get as after the calculation. So, this is another important point, that whenever you calculate something, first thing you check the answers. So, you have to ask yourself, does it make sense, does the answer make sense. So, let us take another example. So, this is I am going to set you as a take home problem challenge as an exercise for you. So, let me explain the problem, and I will give you some hint about how to compute it, how to solve it. So, given a diagram, so do not worry too much about the diagram at the moment. So, it says that there is this yellow is a robot, and this robot is used to make a hole. So, it is used to put this cylinder, this blue cylinder, inside this circular channel, circular hole, and it exerts certain force, which is fixed force, which is 90 Newton. And the problem says that determine the moment of this force P as shown here. So, this is the point of application of the force, and this is the line of action, this is the magnitude, and this is the direction about the points A, B and C. So, different points are given. So, you choose 3 different pivot points and calculate the moment. So, the first thing I will show you is that you can simplify this problem, and so this diagram. So, I have sort of shown you the same diagram in a schematic way. So, this is the pivot point A, this is the pivot point B, this is the pivot point C. So, this is our simplified version of this robot, and this is the point D, where which is the part of the cylinder which is going inside the hole. So, first our system is this robot. Let us choose our system to be robot. Then it is interacting with the cylindrical part. So, this robot is exerting the interaction. So, with the surrounding, only interaction you need to consider is the interaction between these. So, this entire thing is the robot, and this cylinder is pushing. So, it is pushing it down with a force P, and this. So, that means by Newton's third law, there is a counterpart which is trying to push it up with a force, equal force P with an opposite magnitude. So, the robot is giving a force P and the cylinder is giving a force minus P. That is all. All you need to know, so that the force acting on the robot is P in this direction, and this is the force acting by the robot, which is in the downward direction. Okay. So, given this, now we need to calculate the problem asks to calculate the moments. So, then all you need to see that the robot has a complicated shape. So, this dr represents this line of action of the force acting on the robot, force acting on the robot. So, that is dr. So, dr is the line of action of the force acting on the robot. So, now you need to calculate the distance of this line of action from the pivot points. So, as you can see, the distance of the line of action of the pivot point A, and the distance from, so B r in the picture is the distance between the pivot point B and the line of action of dr, and q r is the distance from the pivot point C and line of action dr, and as you can see that these distances are different. So, for the same force the moment are different. So, then the only thing that is required is to use the information provided here. So, this angle is 60 degree, this angle is 45 degree. So, if you draw a line here, this angle must be 60 degree, and this AP is perpendicular. So, this is a 90 degree, this is 90 degree, these are all 90 degrees. Then if you draw a line here and a line here, so this figure says that this angle is 15 degree. So, this so you can see that if you take this line and so this from the geometry this must be also 15 degree, and this is 90 degree. So, this is 60 degree. So, this must be 30 degree. So, this angle must be 45 degree. So, now you know the problem is simply to calculate these distances and multiply the value of the force to calculate the moment. So, the message from this problem is that the same force, different pivot point gives you different moment. So, this is the purpose for this problem. So, I will give you as an take home exercise to work out the distances and calculate the moment. So, we will continue with more interesting examples of statics problems in the next lecture. Thank you.